In this video clip, we will talk about geometric sequence. Look at this sequence. The first term is 8, second term is 24, third term is 72, and the fifth term is 648. So I use A1 to denote first term, A2 to denote the second term, A5 to denote the fifth term. So the fifth term, A5, equals 648. And here there is a great feature, is the following term divided by the previous term is a constant. You see 24 divided by 8 is 3. 72 divided by 24 is 3 as well. So is the case for 216 divided by 72, which is 3. So this sequence is called a geometric sequence. For the geometric sequence, there is a common ratio, which is R in this case. R equals 3. Now, when you have the first term, then in this case, you can immediately write the second term, because the second term can be obtained by first term times 3. You see, 8 times 3 is 24. And 24 times 3 is 72. So here then you have 8 times 3. 8 is the first term, 3 is R. So you can see A2, the second term, equals the first term times R. And then the third term, 72, is 24 times 3. Is second term multiplied by 3. And then the second term again was obtained by the first term times 3. So in this case, if you want to start with the first term, then that will be 8 times 3, and then times another 3, you should get the third term. So 8 times 3 squared is A1 times R squared, which is the third term. Similarly, you have A4 is the first term, 8 times 3 cubed. Then you can see right here, starting with the first term A1, the second term is always the first term times R with the exponent 1. The third term is always the first term times R squared. So you see this exponent is always 1 less than the index 3 here. You can see here is the same. The second term equals the first term. That's A1 times R. R here, the exponent is 1. So then 1 is 1 less than 2. Okay. So here, if you want to write out the fourth term, that will be the first term times the common ratio R times R to the third power. So this exponent is always 1 less than what? The index. Then the 13th term, that's the term we want to get is the A1 times R. The common ratio to the exponent would be 12. So it's a very weak number. Okay. So if you really want to find out that, you have a calculator here. That will be, on the calculator, that will be 8 times 3 to the exponent 12, not 13. Again, is because of what? Because here A2 is the first term times ratio R to the first power. Here, exponent is always 1 less than the index. A3 is 8 times 3 squared. Exponent is 1 less than index. So for A sub 13, the index is 13 equals 8 to A equals to the A1 times R. And here the exponent is 12, 1 less than the index here. If you hit the enter, it's a very big number. You see here, it's like 4,251,528. Very big. So if you want to add all the numbers together, you have to figure out the odd tens. Here, what do we need? We need to find the sum of the first 13 tens. So you got to find 1, 2, 3, 4, 5. And here from 6 to 12, you have about here how many tens? 12 minus 5. So you have 7 tens you got to write out. And then add. It sounds like it's a not easy job, okay? But we'll find an easy formula for that. That would be the task of this video clip. Here we already find 2 important formulas. One is the ratio, how to find it. Is always the term, one term divided by its previous term. So you always use the following term an, either this one, and the previous term will be 216. That's the general formula. And then from here, we have another general formula. That's the second formula. That will be the nth term. For example, n is 13. Then we shall have the first term times ratio r. In this case, is 3. And here will be 13 minus 1, which is 12. So that's the second formula. So we got 2 important formulas. Since this sequence is so nice, we want to develop a formula to find out the sum of the first 13th term. It shouldn't be that hard, okay? Because this series is so nice. Let's find out the formula, and then we can use this formula forever. Okay, so it's right here. You want to add 13th term, so you use S13 to denote 1, 2, 3 until 13th term. We know again, 13th term is the first term times R to the exponent, which is 12. Second term, again, is the first term times exponent. Here is 1. Here is first term. The third term its exponent here is not 3, is 2. Now, here is the way to develop the formula. We want both sides of the equation multiplied by r, which is 3, okay, in our case. So then if everywhere multiplied by r, I shall have this column comes out. H13 times r in this case is 3. You may put 3 here, but you know, we are working on the general formula. So we may put just r. Then A1 times r is here. And then A1 times r, this red term, then times another r, you can put right here. So you have this case, A1 times r squared, and then you times r, you shall put somewhere here. And then the term before A1 times r to the 12th, it was A1 to the A1 times r to the 11th, one term before this term. When this term multiplied by r, you have a A1 times r to the 12th. The last term multiply this red r, you should have A1 times r to the 13th power, because here was r to the 12th. You multiplied by another r, so you got this. You can see right here, I used the 2 stars to denote this expression, 1 star to denote the red equation. Now, and right now, I like to use the red equation, subtract the black equation. What do I get? I put all the negative in front of this black expression. I can see this term will cancel this term. This term will cancel this term. And this term will cancel this term. So only the first term, A1, and the last term, the red one, A1 times r to the 13th power left. That's on the right-hand side. So right-hand side is A1, subtract A1 to the r, A1 times r to the 13th power. That's right-hand side. Left-hand side is S13, subtract r S13. Remember, in front of S13, you have a 1 right here. So you pull S13 out, you have a 1 subtract r here. So left-hand side is 1 subtract r times S13, again, equals right-hand side, which is the first term, A1, subtract the last term in the black equation. Okay, now we both sides divided by 1 minus r, 1 minus r. By the way, here S13 subtract R13, there is a 1 in front of S13. You pull S13 out, is 1 minus R left. So when you do both sides subtract 1 minus R, 1 minus R, you then have a S13 left on the right, on the left, and those two will be cancelled. So you pull A1 out. Inside here again, A1 is A1 times 1. When you pull A1 out, you have a 1 subtract R to the 13th. That's numerator. Denominator is 1 minus R. This would be our formula for the first 13th term. choose the sum. So in our case, A1 again was 8. First term is 8 times 1 subtract r to the 13th on your calculator is 3 arrow up and then 13. The whole value divided by 1 minus 3. Okay. So here on your calculator, you can find out. Turn on your calculator, and you do is 8 times parentheses 1 minus 3 to the exponent 13 divided by, you do not want to write 1 minus 3 with a bracket. You just do is parentheses -2. Because you know 1 minus 3 is -2. And then you hit enter. You have 6,377,288. So that would be this one. 6,377,288 will be this one, the choice. And that was the 13th. The term you are choosing the sum of the first 13th terms, first 13 terms. So here would be 13. So you can see if here is 13, here no longer 12 is 13. But there is an initial term 8 right here. And then in general, we have this formula, which is Sn equals A1 times 1 minus r to the n, and then whole quantity divided by 1 minus r. Okay? So then in this lecture, we have 3 formulas. One, the second one, general term. The third one is this term, sum of the first and 10th. Okay? Okay, I'll see you lecture with those 3 formulas.